Right, today we are graphing quadratic functions, aka parabolas. So off the bat, we need to talk about the two different forms for the equations of our quadratics. The first one should be familiar to you, standard form. This is our ax squared plus bx plus c. That's like the trinomial form that you're used to factoring your double parentheses. So that is called standard form. And in standard form, when we're looking for the vertex of our parabola, we use this, this is called the vertex formula. So we identify our a, b, and c, remember our coefficients and our constant, and we find the x-coordinate of our vertex by calculating negative b divided by 2a. Once we have found that x-coordinate, we find the y-coordinate by substituting, plugging back in that value into our function. So that's how we get the x-coordinate, and then you find the y-coordinate by plugging it in and solving. The other form for a quadratic or parabola is called vertex form, and that is a times x minus h squared plus k, where h and k are the coordinates of our vertex, and then a is that same a value from when we had standard form. So we're going to be able to go back and forth between these two forms, and we are going to be identifying vertices, calculating fun things, graphing, all that good stuff. So let's start with examples A and B. We're going to find the vertex using the formula. So remember that formula is negative b over 2a to get your x value. Plug it back in to find your y value. And that's how we get h and k. So starting with a, my a value is 2, my b value is negative 3, and c is 7. So if we're looking for the vertex, what I'm going to do is substitute negative b. So negative of negative 3 is going to be positive 3 over 2 times 2. Well, that's going to be 3 over 4. Now I need to find my y value. I'm going to be looking for f of 3 over 4. Now this next test is going to be no calculator, so my suggestion to you is do these problems and your homework without a calculator. Practice like you play. A lot of mental math going on here. So that's going to be 2 times 3 over 4 squared minus 3 times 3 over 4 plus 7. Now 3 over 4 squared is going to be 9 over 16. If I multiply that by 2, I'm going to give me 18 over 16. Then negative 3 times 3 over 4, that's going to be minus 9 over 4 plus 7. So to combine all of these, I'm going to want a common denominator. Let's first see what I can simplify. This 18 over 16, that does reduce to be 9 over 8. So 8 is going to be my common denominator. So that would become minus 18 over 8. And then if to put that over 8, that's going to be 56 over 8. So 9 over 8 minus 18 over 8 plus 56 over 8 is going to give me a final answer of 47 over 8. And again, that is the y-coordinate of my vertex. So my vertex is at 3 over 4, comma, 47 over 8. So that is h and that is k, the coordinates of my vertex. Let's repeat that again on B. I'm looking for my vertex, so I'm going to use my formula. Here a is 1, b is 8, so my x-coordinate is going to be negative 8 over 2 times 1. Negative 8 divided by 2 is negative 4, so that is my x-coordinate. Then to find my y-coordinate, I'm going to plug it in here. Negative 4 squared plus 8 times 4 plus 22. That's going to be 16. 16 minus 32 plus 22. Sorry. And that's going to give me 6. So my vertex here is negative 4, 6. That is h, that is k. All right. Now that we've practiced finding the vertex, we are going to be converting our standard form into vertex form. So in order to do that, we need 3 values. We need h, we need k, so our vertex, and we need a. Well, when our equation's already in standard form, we can find a just by looking at it. It's that leading coefficient on our squared term. So once we find the vertex, we can plug all those values into our vertex form. So let's again find our vertex first. Again, negative b over 2a. So that's going to be positive 4 over 2 times 1. 4 divided by 2 is 2, so that is h. Now I need to find k. 2 squared minus 4 times 2 plus 7. 4 minus 8 plus 7. That gives me 3. So that is k. So y is equal to, a here is just 1, so that's going to be x minus h, which is 2, squared, plus k, which is 3. And that's it. So now, one thing we can figure out from our parabola just by looking at the equation is whether it opens up or down. If the outside A is positive, that means my parabola opens up, and therefore my vertex is a minimum. Okay, let's look at D. Again, my vertex formula, negative b over 2a. Negative 2 divided by negative 2 is going to be positive 1, so that is h. Now I need to find k. That's going to be negative 1 plus 2 minus 7, which is negative 6. So there is k. And now plug that into my formula. A is negative 1, so negative of x minus h squared plus k. Now, because A is negative, that means this parabola opens down and my vertex is a maximum. So let's see that visually. Let's graph some quadratics, some parabolas. So these are the steps we follow. We first find and plot the vertex. So if you have vertex form, you just need h and k. Or if we have standard form, we're doing the same thing we practiced on the front page, negative b over 2a, and then find your y value. Then we draw the axis of symmetry. This is going to be the vertical line through the x-coordinate of our vertex. Then we're going to find and plot the y-intercept and its symmetric point. So remember, y-intercept, this is when x is equal to 0. Then we're going to find and plot the x-intercepts. This is when y is equal to 0. And then we just connect our points with a curve. So let's practice this first on example E. Number 1 is to find our vertex. This is in standard form, so I have to use my vertex formula. So negative b over 2a. It's going to be negative 8 divided by 4, which is negative 2. So that's h. Now I need to find k by finding f of negative 2. 2 times negative 2 squared plus 8 times negative 2 plus 7. That is going to be 2 times 4 minus 16 plus 7. 8 minus 16 plus 7 is going to be negative 1. So that is k. So my vertex is at negative 2, negative 1. So I'm going to go ahead and plot that here. And this is going to help me now find my axis of symmetry. That's going to be the vertical line going through my vertex. So a vertical line, the equation is x equals, and here we're going through negative 2. So that's my axis of symmetry. And this is going to come in handy for plotting points in just a moment. I'll show you. Because on 3, we're finding our y-intercept, which is when x is equal to 0. So f of 0, that's going to be 0 plus 0 plus 7. So my y-intercept is at 0, 7. And if you notice from my axis of symmetry, I'm 2 away on the right, which means I'm going to have a symmetric point 2 away on the left from that line. What the axis of symmetry does is it says, for every point I have such a distance away on the right, I have a point the same distance away on the left. Symmetric. I have symmetric points on both sides. So there's 2 of our points. There's our vertex. We can find 2 additional points by finding our x-intercepts. And what this means is y is equal to 0. So I have to set my equation equal to 0 and solve for x. Now, this is going to be easier to do if my equation is in vertex form. So let's do that first. Y is equal to 2 times x plus 2, because minus a negative becomes positive, minus 1. This is what I'm going to set equal to 0, and I'm going to use my order of operations to find, get x alone. So first I move over the 1, then I divide by 2. Now I want to get rid of the square, so I take the square root of both sides. So this is going to be the positive or negative square root of 1/2. And my last step is to subtract 2. So I'm going to get negative 2 plus or minus whatever the square root of 1/2 is. And this is how I get my 2 x-intercepts. The square root of 1 over 2 is going to be a decimal, a really small number. So we're just going to kind of eyeball it here. I'm going to start at negative 2, and I'm going to go, if I add the square root of 1/2, that's going to go to the right just a little bit. And if I subtract it, it's going to go to the left just a little bit. But again, they're symmetric. They're an even distance away from the axis. Just eyeball it here. It doesn't have to be perfect. And there are my 5 points. I'm going to connect the dots and graph my parabola. It is open up, so this vertex is a minimum. let's do this all again on F. Again, step 1 is going to be to find my vertex. I have it in standard form, so I have to use vertex formula. -6 over 2 times 2. We're going to be dealing with fractions here. It's going to be -3 over 2. Then when I plug that in, I'm going to get 2 times -3 over 2 squared plus 6 times -3 over 2 plus 2. So that is going to be 9 over 4 times 2 gives me 18 over 4 plus -18 over 2 plus 2. Simplifying, I get 9 over 2 plus, that's -9 plus 2. So 9 over 2 minus 7, that's going to give me -5 over 2. So my vertex is at -3 over 2, -5 over 2. So -1.5, -2.5. So now my axis of symmetry is going to be that vertical line, x equals -3 over 2. Go ahead and sketch that on my graph. Now I'm looking for my y-intercept. This is when x is equal to 0. So that's going to be 0 plus 0 plus 2. So that is at +2. My symmetric point, this is 1.5 away. My symmetric point will also be 1.5 away. Which brings me to my last step 4, which is my x-intercepts. And that's when y is equal to 0. So again, let's rewrite this in vertex form. 2 times x plus 3 over 2 squared minus 5 over 2. And if I set that equal to 0, I'm once again going to just follow my order of operations. So if this is equal to 0, the first thing I need to do is add the 5 over 2, and I'm running out of room, so I'm just going to continue on to another page. So this becomes 5 over 2 is equal to 2 times. Now I divide by 2, so I get 5 over 4. Take the square root of both sides, so this becomes the plus or minus square root of 5 over 4. And then lastly, I'm going to subtract that 3/2. And that is going to be my x-intercept. So again, we're going to eyeball this. We're starting at -3 over 2, that -1.5. And this is going to be a really small number. So we're just going to go to the right a little bit and to the left a little bit. Again, it is symmetrical. And just doing our best, we are going to connect those dots. It does not have to be perfect. This is certainly not perfect. And this parabola opens up, so our vertex is again a minimum. Okay. And that is all for our day 1 today on graphing quadratics.